Okay, guys. So, kind of cranky because I literally just went through the sheet and now I just realized it was not recording, so that kind of sucks. So let's try this again and hope it's recording. So I'm sorry you can kind of see things because I had to erase everything. So first thing we need to do is rewrite in logarithmic log form. So if we're going to write in log form, we're going to start by writing log. And we're going to take a look at our problem, and it's 8 to the second power, so our base is 8. So it's going to be log base 8. Make sure it's that subscript number. And then with log problems, so we set up so that way it's equal to the exponent. So our exponent is 2, so our exponent goes over here. And then this number that it's equal to is what we're taking the log of. So log base 8 of 64 equals 2. All right, let's do that again. So log, our base is 20. Make sure that's that nice subscript number, little tiny bottom number there. And again, logs are always set up to equal to the exponent, so our exponent is 2. So we should take what this is equal to, and that will be what we're taking the log of 400. So log base 20 of 400 equals 2. All right, last one in this set. So log base 19 this time, and equal to 0, so log base 19 of 1. And if you want to check, you can even punch this in your calculator, should equal 2, punch this in your calculator, should equal 2, punch this in your calculator, should equal 0. All right, let's change it up, let's switch it. We're going to take logs and we're going to write them as exponential form. So log base 15, so that means our base of our power is 15. Remember that these are always set up to be equal to the exponent, so the exponent is 2. And 225 that we're taking the log of is what this expression was equal to before. So 15 to the second power equals 225. You can check that in your calculator. It should give you that. So this goes here, this goes here. All right, let's try this one. So log base 6, so our base is 6. Remember, equal to the exponent, so our exponent is -1, equals 1/6. And think about that. I could do that with my hand, 6 to the 1 to the negative first power. I would flip it, so you know we're going to get that. All right, last one in the set, log base 7. So our base is 7, and our exponent, which is what it's always equal to, is 2. Remember, kind of crisscross here. So it'll be equal to 49 when we turn it back into exponential form. And you could check that in your calculator or your head, and you know that. Right, next part, evaluating the expression. Actually, whoops, sorry there. These were set up to be able to do without a calculator, but you guys are at home and you have everything at your disposal, so I know you're gonna grab your calculator. But I just wanted to show you how we would do this in class. You actually do not need a calculator for these. I'm gonna set them equal to x, just so it's easier for me to rewrite. So I'm gonna turn this from a log form into exponential form, just like I was doing the previous problems. So base 6 of raised to the x power equals 36, and if x is our variable, 6 to the what power equals 36? 6 times 6, so that'll be 2, so x equals 2, or you could punch this in your calculator, and I'll show you how to do that in 1 second, but I just want to show you that you can do this by hand. So I set this equal to x. We're going to change forms like we just did the previous problems. So our base is 3, our exponent is x, it equals 81. That's a little bit bigger, but since I have calculator, I can use it. Or you can think about it in your head. Let's see. 3 times 3 gives me 9, times 3 gives me 27, times 3 gives me 81. So it's actually 3 to the 4th power. But let's talk about calculators because we've got to do it for these problems down here. I apologize, I'm using a different way to kind of record this. That way I can use my hands and not hold the phone while I'm trying to record things. But you can't see the screen on the calculator all that great. Sorry. So what you're going to do is, in order to put this in your calculator, there's a couple different ways you could do this. If you have one of your fancy schmancy calculators, what you could do is you could hit alpha, and you're going to hit this second key here, window. Oops, not on. Well, that would help. Alpha window. And then the last option, number 5, is log base. And you could actually put in, for like this problem, I have log base 3 of 44. It's a little, let me see if I can get this a little closer to y'all. Yes, I said y'all. I'm having a little fun with it. All right, so there we go. And I punched that in my calculator. I hit enter, and I have 3.4. It says thousandths, so tenths, hundredths, thousandths would be 4 here, but the next number is 5, so it's going to round up. So we'll put 5. All right, now if I did not have a fancy schmancy calculator that will change the bases of my logs, oh look, you can kind of see it a little. Oh, who knew? Okay, now I do. So just in case you didn't have a fancy schmancy calculator, I just got to hold it up on the angle here. What I can do is I can use the base change formula. The base change formula is you can take common log, this button right here, your calculator, nope. This button right here, this common log, every calculator should have, oh now I'm holding out too much on angle. Every calculator should have this one. So what I would do is I would do common log of 44 over common log of 3. Sorry, that should be a small number, big number. So that way, this goes on the bottom, this goes on the top. I do common log of each of those, and I divide, and it'll give me this number as well. So you don't need a fancy schmancy calculator if you know how to do the base change formula. So one more time, and actually can show it in the calculator this time because now I know the trick. So you're going to hit alpha, and you're going to hit this button right here. And look, the last one lets me do log base. I'm going to put in 5, and I'm going to put in 3.4 for that last problem. Hit enter, and it's going to give me 0.760. It stays 0 because the next number is 3. But if I didn't have fancy schmancy here, I would do log of 3.4 over log of 5. Actually, let me show you that. So I would do common log of 3.4, let me close that, divided by common log of 5, and look, it gives me the exact same decimal. Awesome, right? All right, so this is the end of the first page. Hopefully it was recording. Let's see, cross fingers. No, it wasn't.